In this module, we will talk about the determination of KLa with different techniques, but in this technique, we will talk about the sulphite oxidation technique. As we know that the KLa, volumetric mass transfer coefficient, is very much important in aeration and agitation and in a fermentation process. If we know the KLa, then we can drive our fermentation process in a good manner. So the determination, as we know, that is a very essential to establish the aeration efficiency and to quantify the effect of operating variables, mean agitation, and on the provision of the oxygen. So it is important to remember the dissolved oxygen. So if we just monitor the dissolved oxygen in the fermentation process, then we can create that the dissolved oxygen on various points. Then we can calculate the dissolved oxygen tension, because if the consumption is less and the solubility is more, then there will be go to the saturation point. If the consumption is more and the solubility is less, then there is a tension. So that is the driving force which I have already told you in my previous module. So the dissolved oxygen tension. So if we describe the oxygen transfer that are based upon the dissolved oxygen concentration, so the OTR and DOT are very interlinked. The solubility of the oxygen is affected by the dissolved solutes, so that the pure water and the fermentation medium saturated with the oxygen would have different dissolved oxygen concentration, yet have the same DOT. If the dissolved oxygen tension has the same, but the solubility has varied. So simple, the oxygen electrode with record as if we know the soluble oxygen just by an electrode, that mostly required 100%. Anyhow, if we just keep that the maximum tendency and the solubility of the equation is 100%. So that can be. So the DOT in concentration, the solubility of the oxygen in the fermentation medium must be known, and this can present with different difficulties. So in the later slide, you can see that sulphite oxygen technique is also available just to measure the soluble dissolved oxygen. This technique does not require any measurement of the dissolved, but relies on the rate of conversion. It's a chemical methods, mostly used in different environmental experiment just to know the dissolved oxygen present in different lakes, etc. So when an oxygen enters the solution, it is immediately consumed, the oxidation of the sulphite, so that the sulphite oxidation rate is equivalent to the oxygen transfer rate. Since the dissolved oxygen concentration is 0, then the KLa may be calculated from OTR is equal to KLa dot C star. So these all techniques actually just to calculate the KLa. So if we start the fermentation process, and we know that at the start, suppose there is 0 oxygen, and then either that will be jet loose oxygen, we just sequester all the oxygen, and then that related to that a 0 point, and then we start. So by this, then we cut the oxygen transfer rate is totally equal to the KLa multiplied with the saturation point. So the volume of the, in this method of dissolved oxygen concentration, the volume of the thiosulfate titrations are plotted against the sample time, and the oxygen transfer rate may be calculated from the slope of the graph, and then we can calculate easily the OTR of that sample.